So the tutor is here Monday through Wednesday during the day. On Thursday, he's here during the evening. You can send him email. Like I said, awesome. He could teach the class. He'll help you. Strongly recommend him. So especially for the folks who haven't turned in the last few assignments, if you're stuck, if you're not understanding it, talk to him. You'll get a good grip. All right, so I mentioned that I want to cover the idea, excuse me, of defensive programming. Defensive programming, for Pete's sake. Excuse me for a moment. Defensive programming is the idea that you write your programs in such a way that they can't crash, right? Playing Counter-Strike, you're going to be annoyed if your program crashes, right? If you're using Word and suddenly you get that Windows has encountered an error, application is shut down, and then you lost the English paper you're writing, you get enraged, right? You try to write your programs defensively. So, let's make some notes to that effect, right? That's my name. If you turn in a program without comments, I get really frustrated because every single time we come in here, we demo writing programs with comments, right? So, you've had good examples, or at least, somewhat. You don't have to type 20 pages of notes like, we do during class. But, you can put a comment block up at the top and you can describe, some of your if statements and stuff like that. Write your code in such a way that you could then show your code to somebody who doesn't know how to program, and then they would be, they'd at least have a fair idea, a gleam in their eye about what your program was trying to do. All right, so we're going to talk about defensive programming. Not defensive. Not defensive. There we go. So, defensive programming, writing code that accepts bad data without crashing. So, you ask for a number, but the user types in something that's not a number. We can try to accommodate that, right? When we call float, if they included a $sign or if they include any letters or stuff like that, it will crash. So common problems. The user enters non-numeric data, right? No digits. That's the big one that we could fix. And we could fix it by writing a module, right? That takes care of handling all this for us. Now, there's kind of a advanced feature of Python that we could use to catch any crash and stop it from really crashing. And that's called exception handling, where you put your code in a try block and then you have an except keyword, and the except keyword gets activated if there was a crash, and so it doesn't crash after all. Now, I don't want to do that because I want to practice stuff that's not specific to Python. So, if we ask the user for data, right? Age is equal to input. What is your age? Question mark. Something like that. And then we do age is equal to float age. And I know that all of y'all know that you could, put that all in one statement rather than two. Now, for this case, I want to go ahead and break it up into two. And the reason why is I might want to make sure that that's a number. Now, unfortunately, floating point data is a little bit harder to verify because a period doesn't count as a number. I wish it did. But until we get to that point, until we get to the point of handling the period, we can at least make sure that it's all digits. And so we can use a feature of the string class called isDigit that checks to see if it's all digits. We would need to do that before we actually try to convert it. So something like this. If age dot is digit, that means everything in it is false, or equals false, sorry. If age dot is digit, parentheses in parentheses equals false with a capital F, colon, then we're going to print an error message. Print digits only, end quote, in parentheses. Else, age equals float age. Now, like I said, that's not the best solution because it only allows, right, pure digits. It doesn't allow decimal points. We could write a function that would allow digits and decimal points. That might be worth doing. I think that'd probably be worth doing. But let's go ahead and run it and just prove that it rules out data with decimal places. I mean, it rules out in non-numeric data. That's what we want to do. Elemental PQ R, Lecture R, I believe. So I'm going to run it. What is your age? Say I type in something wrong. All right, well, I typed in something right. It didn't crash, although the fact that I typed in 912 is kind of suspicious. We should check for reasonableness as well. Well, I'm going to type in, whoops, I accidentally hit a D while I was typing in the age. Digits only. So, besides ruling out non-numeric data, we might want to check for reasonableness. Right, we might want to make sure that the age that they're entering is greater than 0 and less than 120, if that's the maximum age that we can predict, right? I think that very, very, very few people in the universe or on the planet have lived to be past 120. Maybe that's even low. Maybe we might want to make it 150, right? Or we might want to ask them for their birth year, but not allow them to enter a birth year in the 1800s, right? Or a birth year that's greater than, 2012, 2017, 28, whatever year we're on. I'm stuck in the past. Sorry. Okay. So we've seen this one, I hope. I hope that worked for y'all. I'm going to comment it out now so that we're not asking too many questions. Because every time we write one of these that requires input, then every time we test it, we have to type in an answer. That's kind of a generic. It's not really that great, right? Because it tells them what they did wrong, but it doesn't let them type it in again. That's not too cool. What we should do is be looping and only allow the loop to exit when they finally have typed in good data. We'll get that going in a minute. And the loop we write is going to look actually kind of complicated if we throw in everything that I am talking about here. We'll see how far we want to take it. And I'm not expecting you to do defensive programming in your code unless I specify it, right? If the assignment says make sure that it doesn't crash if they type in $, something like that, then yeah, then I want you to do it and you wouldn't get full credit for it. Okay, so this is going to be an example of checking for reasonable data. Unreasonable would be if they typed in a negative value for their hours worked, right? Or our company policies do not allow more than 80 hours a week, right? Something like that. So let's do that. Print, parentheses, quote, enter number of hours worked this week, end quote, in parentheses. And then hours equals input, parentheses, quote, whole numbers only. And then a little caret to tell them where to type, end quote, in parentheses. And then we want to convert that. Now, since it's whole numbers only, we might want to use int. On the other hand, using float's not a bad idea, but that would still let them get away with typing in 100.5. Now, I'm kind of a jerk as an employer if I don't let them work that half hour, but this is just an example. Another example would be if you say, enter a menu choice, 1 for, bracelets, 2 for necklaces, whatever, and they type in 1.5, that'd be silly. You might want to let them know that they typed in some bad input. Okay, so let's convert it to a float first, and then turn it into an int. No, we're not going to do that. Let's just turn it into an int. Hours equals int parentheses hours. Now that's a statement that can crash, right? If they type in something that's non-numeric, that statement will crash. So we need to fix that again with this code. If something dot is digit, we want to make sure that it is all digits. So rather than use equals equals false, I could use equal equals true, and then just put my positive clause up there, my true clause up there. So let's try that. Let's see if we like the way that looks better. If hours dot age, if hours dot is digit, colon, let's convert it. This statement should have gone before the hours equals int hours. I'm going to erase them both because anytime I start copying and pasting, I mess people up. So if hours dot is digit, parentheses in parentheses colon, let's do the conversion. Hours equals int parentheses hours. Else colon, let's tell them that they typed it wrong. Print parentheses quote, whole numbers, parentheses, digits only. End quote, end parentheses. And again, we should be looping. Make sure that we get good input. Now what can we do if the user types in something that's lousy? Are we just going to quit the program? That's kind of lame. Are we going to, I should let you answer it. Yes, sir.
We'll give them an error message.
Yeah, we're going to give them an error message. That's a better thing. Giving them an error message and then quitting the program is kind of lame. Yeah, it's better than nothing. Giving them an error message and telling them that we're using a default value is second best. Best is giving them an error message and then looping until they give us a good one. That's the best. So we'll get there. All right, so there we go. That handles that, but that doesn't show us any more than what we had already. Notice the difference between the way I coded it. Here I coded it if is digit is equal to false. We could rewrite this by saying if not, and then getting rid of that equals false. That'd be a more professional way of doing it. But here we check to see the false clause, and then we printed out the error message, else we did the good work. Here we checked for the true, right? If ours is equal to digit, then we did the good stuff, else we printed out the error message. We just kind of flipped it. I kind of like doing it this way better because I like to rule out the mistakes early and then have the rest of the code use the good data. Let's go ahead and give them a default value for the hours, just because that is a possible solution, right? Print, parentheses, quote, hours defaulting to 40, because that's a regular work week, right? And then hours is equal to 40, right? Now that's not ideal, and if you are going to make it loop until they enter good data, there's no reason to default it, right? You're going to choose one technique over the other. All right, now let's check it for reasonableness. We're going to make sure that they haven't entered a negative value for hours or something more than 100. Those are our limits. If you're working more than 100 hours a week, you need a vacation. So our limits. Let's define some limits. Lower, let's do it the lame way without defining our constants, just because I don't want to fluff up the example too much. So if hours less than 0 or hours greater than 100, colon, we're going to print an error message. We're going to print invalid, hours must be between 0 and 100, in parentheses, end quote. I know you can't see the whole string on my writing because the text is too big, but invalid, quote, parentheses, print parentheses, quote, invalid, hours must be between 0 and 100, end quote, in parentheses. And if that's not the case, then we could throw in an else and do all of our good work. Whoopsie. Right there, right? Else colon, you know, and then proceed with our code. I'm going to modify it a little bit, maybe. No, I think that's okay. I think it's okay. And then we can calculate whatever, right? Whatever we're supposed to be doing. Minutes is equal to hours. Minutes equals hours times 60, or whatever. Do whatever we needed to with the data. Print parentheses, quote, hey, in minutes, that is, end quote, comma, minutes. Right. Whatever we needed to do. Now that sure is a lot of programming. That is a lot more programming than just input equals float parentheses, or, you know, hours equals float parentheses input parentheses enter number of hours. Well, that's the way of it. Unfortunately, to write defensive programming, programming that runs with fewer errors, takes a lot longer than writing something that just assumes the data is going to work. You can wind up with a program that's, you know, more than 50% error handling, and that seems like a waste. But if you have a client who's paying you to write their program and their program is quitting half the time, then they're not going to hire you to write any more programs. Or they're going to keep asking you for changes to prevent that until your code has hit the point where it's 50% error handling anyways, or more. It's better to build it in. On the other hand, when you're just proving your equations, right? You just want to prove that you can calculate over time and stuff like that. You can make a rough draft that that's all it does. But then before you're finished with it, you ought to go ahead and make it defensive. Defensive programming, error-proof programming. All right, that's a little bit better. I still want to loop until I get some good data. And I'm going to make that a third example, but I want to make sure this works first. Let's run it, make sure it works for everybody who wants to get it to work. Whole numbers only. All righty, what if I don't type in a whole number? 9.0. Whole numbers only. Cool deal, it didn't crash. It would have otherwise. So hours defaulting to 40. Hey, in minutes that is 2,400. Sure enough, it is. So the program didn't crash. It substituted a default value. We did some testing. Let's test it again and enter some unreasonable data, something less than 0. All right. Whole numbers only. -1. Whole numbers only. Well, the fact that it's not allowing a minus sign as a digit is another one of those pains, right? Just like a period should be counted as a digit, shows it a minus sign. But you kind of have to be careful, because what if they typed in minus $4.00, right? That's a whole bunch of things to check for, and then they could have messed that up, right? 4 minus $, dot, and then another $, and are we going to allow that input? No. So validating input and letting them put in $signs and stuff like that is a more difficult thing. And that's why quite a lot of the time on the web you'll see a thing where they try to prevent you from typing in that kind of stuff altogether. If you type in a $sign, it doesn't even show up in that field. Or you get one of those annoying fields where you have to pick your birth date, and if you're old like me, you have to scroll way, way, way down to 1967, and stuff like that. Or, you know, if you're picking what, you know, country you live in and they don't put USA up at the top, it's kind of annoying because you have to cycle through 700, you know, countries before you get to USA. So anyways, we have done some good defensive programming here, but we also want to demonstrate looping until we get good data. To simplify that example, I'm not going to do the rest of this stuff. I'm not going to do the defensive programming here where we check to see if it's whole numbers only. Oh, we could. That's not a bad idea. Nah, let's just do this check here. I don't want to combine all the techniques and make them so complex that it's hard for us to comprehend. Anybody need eyeballs on your screen because stuff didn't work?
I am getting that.
All right.
I'm getting that error message.
One thing you need to be careful about is to make sure that you do these things in the right order. If you did, don't do this, hours equals int hours there, which I started to do. And so if you followed along with me, you probably didn't catch me deleting it. Anyways, what's wrong with this? This could crash. We don't want to do that until we're sure we have good data. So that's why we don't want this before the if statement. All right, so the last example is going to be looping until we have good data. Again, I would like to comment this stuff out so that we don't have to type it in every single time, right? So 3 quotes up at the top, 3 quotes up at the bottom, looping until we get good data. We're going to ask the user to enter A, B, or C. And if the data is not equal to A, B, or C, then we're going to tell them that they made the wrong choice. Or we could use 1, 2, or 3 or something like that. So what we're going to do is we're going to declare a variable called valid, and we're going to set it equal to false. And we're going to keep looping until we get some good data. So while valid equals quote false, and in this particular language you have to capitalize false, in others you don't. While valid equal to false, we're going to ask them the question. And if they didn't give us some good data, then we're not going to set valid equal to true. So let's ask them the question. Print. Do you want to A, B, or C? Question mark. In parentheses, end quote. Choice equals input, parentheses, quote, and a little arrow to tell them where to type. Now we're going to check. We're going to make sure that that's good data. Now one technique that is useful is if we turn the data uppercase so that it's okay for them to type in lowercase or uppercase. That's not too hard to do. We may as well demonstrate it. Choice equals choice dot upper, parentheses in parentheses. And we may be using things that we haven't seen before. I don't recall if we'd seen is digit or upper yet. Have we? Have we seen is digit and upper? Feel free to thumbs down it. No? Okay. Nobody's saying yeah, so I believe that we haven't talked about it. But it's okay to introduce new topics as long as you're getting the basic idea. This is just for convenience. So if they type in a lowercase a, b, or c, let's add a comment to what this does. Converts to uppercase. Now in the jewelry assignment, I believe, somebody did something that's really awesome. And so it shows that they had researched the Python language and figured out something that we haven't really covered, I don't think, which is to do this. And then I'm going to comment it out because it is a little advanced for what we're looking at. If choice space in parentheses, quote, ABC, end quote, colon, then it's good data. Valid equals true. That's actually an excellent way of doing it. And I almost feel bad for commenting it out. It's just that it demonstrates something that I don't think we've done yet, which is using the in keyword to search a list of letters to see if it's in there. Well, I'm going to make a comment that this is a really good way. This is a great way. But I'm going to comment it out, like I said, because it's using a technique that we really haven't hit in the past, and I don't want to throw too many of those. We already have thrown in dot upper and dot is digit. So, if choice equals quote A, or choice equals quote B, end quote. Now I'm going to throw in a backslash here just so I can type on the next line, but you don't have to. And if you don't type on the next line, don't put the backslash. Or choice equals quote C, end quote, colon, then valid equals capital T true. Else we better print out an error message. So as soon as y'all type valid equals true, you're going to back tab one level and you're going to have an else. So else colon, print, choose A, B, or C only, end quote, in parentheses. And then I'm going to put an end while here as a comment. Don't put that in there without a comment if you're trying to write Python code, or else it's a syntax error. And one of the syntax errors I saw is somebody just did that in their code. They put an end while or end if without a comment sign in front of it. And so it crashed when it hit that point. If that's all it is, just put a comment in it, run it again, and it'll probably work. I rarely tell you exactly what the syntax error is because you learn more by figuring it out yourself. The best learning occurs when you put dents in your forehead by banging it in your keyboard, right? Now, when we're doing stuff in class, I go ahead and wander around because time is of the essence. And then let's print a message. Print, you chose, end quote, comma, and then their choice. All right. Looping until we get good data. The book definitely talks about this. Excellent use for repetition. Now we could do all sorts of checks here, right? We could do range checks. We could use is digits if it was for a number, and we only set valid equal to true if it passes all the tests. If they type in anything wrong, we print out the error message, and we don't set valid equal to true. The idea of looping still works. So you can kind of see that adding all these things together could make for a really long chunk of code just to ask them to enter a letter or to enter a number. That's what modules are for. If you put all this in a module, then you could call it over and over and over, and you could copy and paste that module into your new code whenever you're going to write it. And you'd be really well off, right? Because then getting the input would just be using one line. And I should demonstrate that, but I think we have other things we might want to talk about. Is this working? And so down here, of course, is where we actually use that choice. And I'm going to test it a few times, make sure it accepts lowercase, make sure it accepts uppercase, see if it rules out bad data. You want A, B, or C. What if I type in lowercase? Awesome. A, B, or C. I'm going to type in uppercase. Cool. Now I'm going to test it with making a choice that's not on the screen. All right. D. Choose A, B, or C only. A. All right. Good defensive programming. Who knows if today's homework is going to involve that or not? I haven't decided yet. Let's make a few comments down here about the special features. that we have demonstrated in here just because we haven't seen them yet. New stuff, right? S dot is digit, parentheses in parentheses. Returns true, whoops, capital T here. True if S is all digits, otherwise false. Unfortunately, doesn't allow points and minus signs. Unfortunately, returns false for decimal and minus symbols. We could write a function that would allow decimals and allow minus signs. We'd make it a module so that you could use it over and over and over. Once you take the time of writing something complicated, unless it's too specialized, right? I mean, if it's a function, if it's right, you know, drawing your name in turtles, and maybe you're not going to use that over and over and over. But this kind of stuff, validating your input is. Okay, so is digit is one of them. And an S equals S dot upper, parentheses in parentheses, converts S to uppercase. And guess what? There's an S equals S dot lower as well, if you'd rather check lowercase letters rather than others. S equals S dot lower, parentheses in parentheses, converts S to lowercase. And I hope you realize that when I say S is equal to, that's just a variable name. It's a stand-in for a variable name, right? I remember being really annoyed in the first grade because I thought I figured out what blank meant, right? Because the teacher would say something like, the blank is in the, you know, is in the doghouse. And so I thought, okay, blank means dog. And so the next time she said blank, I thought it meant dog, right? No. Blank is not a dog. A blank is something that gets filled in. The S gets filled in, right? So it could be hours equals hours dot upper, or choice equals choice dot lower, that kind of stuff. Same thing here, right? Age dot is digit, if that's your variable. I'm just using S to represent string here. So, in the above cases, or in these cases, S represents a string. And one more, that IN keyword. If, I think I'm going to say if X and Y, colon. Returns true if X is found in Y, false otherwise. And so our example was if choice in parentheses quote ABC end quote in parentheses. That's our example. And so kudos to you who authored the program that used that syntax for validating your input. All right, so all of these are examples of defensive programming. And at least tuck them away in your brain so that if you take a future programming course or you start doing this professionally, that you remember you can do it. Even if I don't ask you to do it in this class. And I should at least ask you at least one time to do some defensive programming and tell you what kind of data to rule out, right? Rule out temperatures of below negative 275 degrees Celsius, because I think that's absolute zero, 273, something like that. That kind of thing. Unreasonable values. If you're letting somebody enter the number of items they wish to order, you could tell them if they've ordered more than you have on hand in inventory, right? That kind of thing. We all good? Typos, no typos? All right. So good old looping. as long as the condition remains true, the statements in a while loop will continue to execute. And the stuff that's tabbed in it is called the body of the loop. And we just demonstrated a loop. We demonstrated everything that was on here. Well, we did not demonstrate a counter. We have done that in the past. But we did demonstrate everything down here and this statement. So as long as the condition remains true, the body will continue to execute. You can control your number of repetitions by having a loop control variable, which is initialized to a value that causes it to go into the loop. And then the while statement tests the loop control variable. And then the body of the loop has to alter the loop control variable, or else it's an infinite loop. And the repetitions can be controlled by either a counter, right, if x is 1 to 10, something like that, or by a sentinel value. And in this case, our sentinel value is the value true. When valid became true, then it stopped. I'm going to scroll back up here, and we're going to check to see if we have all that. This is our loop control variable, right? It controls whether we're in the loop or not. So that's our loop control variable. Variable. And this is our condition. The rest of this stuff is the body of the loop. Everything indented is the body of the loop. Now this is making our code a little bit harder to read, but you know that when you're doing your own programming, you can remove all these comments. You don't need all this stuff. And then lastly, down here, we have to update the loop control variable, or else it will never leave the loop. So I'm going to go under this example as soon as I hear the typing stop, and just add a comment as to the 4 parts of a loop. All right. So down here, I guess I could just put it inside the triple quotes here underneath, above new stuff. Loops need 1, a loop control variable, 2, a condition, 3, a body, which includes a way to update the loop control variable. Now all of that is true whether we're using a counter-based loop, a for loop, or for x in range loop, or a loop like this. The only time that a loop kind of goes off the rails here is if we use something that the book doesn't show, the while true loop. But this is a classical definition, and so it's important to learn the classical ideas as well as learning ways in which we can twist them. And then you can have a counter-based loop. Same idea. X is equal to 1. That's your loop control variable. While x is less than equal to 10. That's your condition. And then print x. And then x plus equals 1. This is all the body that updates the loop control variable. So again, those are the 3 things that were necessary. 1, the loop control variable. 2, the condition. And then 3, the body that updates the loop control variable. So a definite loop is one that just goes a predetermined number of times. X is equal to 1 to 10. We have a predefined list of names. We're going to step through those. Why don't we go ahead and demonstrate that just so that we'll recognize it again in the future. So I'm going to do an end quote here, a triple quote here. So for name, space, in space, square brace, quote, Bob, end quote, and I'm adding spaces to make it easy to read. Bob, end quote, comma, Fred, end quote, comma, Zeke, end quote, close square brace. Put a colon at the end of all of that, and then print name. That's just a way to step through a list. In this case, it's a list of strings. It could be a list of numbers as well. Could have been for name in square 1, 2, 4, 8, and it would go through those numbers. Yeah, that's going to get tedious. Okay, and there we go. Bob, Fred, and Zeke. That's another example of a loop. This is another form of definite loop. A definite loop can be a counter-based loop, or it can be a loop that steps through a list or steps through a range. Stepping through a range is another counter-based loop. So I'm going to add a comment saying that that is an example of a definite loop, which could be a counter-based loop, a loop that steps through a range. The fancy word for step is iterate. And a loop that steps through a list, which is the above, as shown above. This thing could have been defined ahead of time, and it probably would have been something like name list is equal to Bob, Fred, and Zeke, and then for name in name list. We can do the range example. For X in range, parentheses, starting at 10, comma, going up to 31, which is actually going to go to 30, parentheses, quote. For X in range, parentheses, 10, comma, 31, in parentheses, quote, and I'm going to add a comment that this goes from 10 to 30, because what this means is go until X becomes 31, which means it's only going to go up through 30. I wish you just put 30 there to count. Whoops, I made my comment wrong. Goes from 10, it's seductive, right, to think that that means that it's inclusive, but it's not. And then we could print, parentheses, X. Now I'm going to show you something a little bit fancy, just because. What if you wanted the values of X all on one line, rather than on separate lines? You can use the end parameter of the print statement. Totally optional, unless I ask you to print everything on the same line. But the way you do that is print parentheses X, comma, and then the word END equals, parentheses, excuse me, end equals quote, space, quote, end parentheses. And then when you're ready to go to the next line, back tab all the way, and then just print a blank line. So what's this going to do? This tells it to not end every line in a slash n, not end every line by going to the next line. Instead, every print is just going to be ended by a space, so to keep putting them one after the other after the other. And then finally, when we're done printing all that stuff out, we'll go to the next line. All right, now it's kind of stupid to try to print all that many numbers on one line. The output may be really lousy looking, I don't know. Maybe I should have chosen a smaller range of data. It'll prove the point though. And I crashed it. I did something wrong. All right, so I printed out all the numbers from 10 to 30 all on one line because that end parameter. Just tuck that away in your brain. If you ever want to print a list all on one line, go for it. I don't think I'm ever going to ask you to do that. I just want you to see it. I'd like for you to see more than what is strictly necessary. So if it sticks in your brain, that is good. So we've seen a counter-based loop. This is an example of a counter-based loop. We've seen a loop that steps through a range. That's also a counter-based loop. And we've seen a loop that steps through a list like that. If we were going to do the same thing here, without the for statement, it's going to take more code. And I'm sure that I've demonstrated this. This is your loop control variable. We would have to initialize it first. So this is the same, but written with a while. So this is the same, but written as a while. Let's initialize our loop control variable. X equals 1. And then our while is going to be while x is less than 31. Or you could say while x less than equal to 30. While x less than 31 colon. Just copy that line up there, that print x end equals, right? Save time typing. Print parentheses x equals. But then we have to update the loop control variable, or else it's an infinite loop just printing out 1 over and over and over and over, which I almost always do when demonstrating a while loop, so I'm amazed that I remembered. X plus equals 1. And then after the while statement, let's print our blank line, hit our character turn. All right, so that's the same as the loop before it. I like this syntax better. It's cleaner, right? It only takes, this one statement does all three things. It initializes the loop control variable, it has the condition in it, and it has the update of the loop control variable, all in one line. So it's easier to type. You don't forget to update the loop control variable like I do half the time. All right. And so it did the same thing twice. An indefinite loop is one that we don't know in advance. It's not a counter-based loop. It's not stepping through a series of values. We don't know how long the user is going to sit there typing in invalid data until valid gets set to true. We don't know how many times they want to play the hangman game and keep hitting Y to repeat the game until they type in no to quit. So indefinite loop, program does not know in advance. How many times to repeat. And our examples. We don't know how long the user will sit there entering bad data. We don't know how many times they want to repeat the game. We don't know how long the file is. Although in Python it's actually more of a definite loop. But anyways, that's the idea. Definite loop is counter-based or stepping through a series. Indefinite is something like while not valid. The sentinel-based loops. We have been writing indefinite loops with sentinel values. And y'all remember what a sentinel value is. It's just the value that ends the data, ends the series. Enter test score, or negative 99 to quit. Negative 99 to quit. Do you wish to play again? Yes, no. If they type in no, that's the sentinel value. It causes it to quit. Our valid was a sentinel variable, right? And it kept repeating until valid became yes. So yes was the sentinel value, which sounds weird, right? But yeah, that was the sentinel value. So as mentioned, belabor the point, but the book sure does. In your loop, you provide a starting value for the loop control variable. You test the loop control variable to see whether the body executes, and inside the body you modify. Something can modify it. X gets updated, add 1 to X, or we ask them if they wish to repeat, or we set valid equal to true when they finally get it right. In our guessing game, we had a variable called correct, and we kept repeating until correct was equal to true. So nested loops. Loops inside of loops. I don't remember. Did we modify our guessing game? I think we did, so that you could say again at the bottom that you wanted to repeat. We kind of demonstrated that at least. I see very few people nodding their heads. Maybe. So we had a loop in our guessing game, which was correct while correct equals false, right? But then we added, although I didn't make you upload it, a loop that said, do you wish to play again? Do you wish to repeat? And so that was a nested loop. Right? While, complete equals false, right? Keep repeating until they got the right answer. But then we enclose that in another loop. While play again equals Y, something like that. This is called a nested loop. The whole body of the game was in here, and then you had your end while, and then we had another end while where we asked if they wanted to play again. Input play again, and then that was the end of this loop, another end while, like that. Nested because this loop is inside the other loop. This loop has to complete before the outer loop will repeat even once. And so sometimes there'll be a question like, can nested loops overlap? And no, they can't overlap, right? This one's got to repeat before it comes down here and asks, do you want to play again? And it repeats the whole thing. So flowcharting a nested loop, and I know that we have demonstrated something like this already. If something is true, if our part counter is less than the number of parts, then we ask them a question. And if that question is true, we keep repeating this stuff until this is no longer true. Then it comes down here and it adds 1 to the part counter, and it loops outside the loop, right? So this is our nested loop, this is our inner loop, and the part counter less than parts is the outer loop. So nested loops never overlap. The inner loop always has to complete and has to be completely contained within the outer loop. So the inner loop goes through all of its iterations, that's our fancy word for it, each time before its outer loop can go even one more. And the total number of iterations is the number of inner loop repetitions times the number of outer loop repetitions. And that's not strictly true. Yeah, I guess it is, right? If it takes them 10 guesses before we ask to play again, and then they play again 3 times, 10 guesses times 3 times is 30 iterations. Common mistake, neglecting to alter the loop control variable. If we never set valid equal to true, it'll never pretend that we had valid data. If we don't update x, then x will always be less than 10. If we don't ask the user whether they want to play again, then it'll play again infinitely. And it's always incorrect to create a loop that cannot terminate. Now, if I've demonstrated while something, or while true, do something, then there is a way to terminate it with a break statement that doesn't look like this logic, but I'll never ask you to flowchart it because it's not textbook perfect, at least this textbook. Another mistake, using the wrong comparison. Do you want to play again? What if I had checked to see if this was no, right? While play again is equal to no. There should be two equal signs there, right? That's the wrong check. It wouldn't even go into it. And if they typed in no, even if it somehow did get into it, then it wouldn't play again. So you just have to make sure that your check is there. That's correct. So mistake, including statements inside the loop that should have been in the outside of the loop. You're calculating the average test scores. You've got to add up all the test scores before you can calculate the average. Print it out. That calculate the average and print it out ought to be at the bottom, outside of the loop. You don't need to print the total as it's going through it, right? The user enters 100. Then you print total equals 100, average is equal to 100. Then the user types in 60. And so it says total equals 160, average is equal to 80. You don't need to see that every loop unless you think that that's really useful information. It's more useful to calculate the average and display the average and the total down at the very bottom, underneath the loop. You just got to make sure that you don't put stuff inside the loop that belongs outside the loop. Silly example. Nah, I'm not going to give you a silly example. Yeah, I'll give you a silly example. We have a game, right? While repeat is equal to yes. We have a loop that controls our game. Blah, blah, blah. That's our body. And then later on, we ask them, right? Repeat equals input, parentheses, quote. Do you want to play again? End quote, in parentheses. And then we print parentheses, quote, done there, right? It's going to print done no matter what they type. That's not what you want. The last statement should be outside of the loop. All right, so we are going to do a little bit of homework on the concepts in here of the defensive programming. What we're going to do is we're going to take a previous program that you've written and modify it to have some defensive programming in it. Now, the interest calculator has too many variables, right? They type in 5 things, and I don't want to make you do 5 different things. But the pay calculator only takes 2 pieces of data, right? Number of hours worked. So that's going to be our homework assignment. Revise the pay calculator, or write a new one that does defensive programming by validating that, 1, the data they enter is all digits. It won't allow decimal points, but too bad for this example. And 2, that the hours cannot be negative, or that the hours or the pay rate. And I hope y'all remember how to calculate overtime. If you can't, just look at your prior assignment. As a matter of fact, I don't care if you put in overtime in this one or not. Calculate overtime, or just do hours times rate. Your choice. So there's going to be 2 loops there, it looks like to me. So I'd rather you use loops rather than default values. So this example is going to look most like the third example we did. Well, it's going to be a mix of the techniques. So if you get stuck on it, ask me about it, right? Send me a picture of your code, I'll give you suggestions. Not enough students take advantage of that. When we're only getting 10 out of 22 students actually doing submissions, then that means that a lot of people have questions and they're not asking. So y'all got my text numbers, I hope. Take advantage of it. I'm up late. Alrighty. I think we could call ourselves done there. Well, we have a few more minutes. So a for statement, a for loop, is a definite loop because it initializes, it tests, and it alters all in one statement. Now their example here is not Python, but it's the same idea. For count equals 0 to 3, step 1. Instead we do for range equals, for count in range 0, 4, 1, if we want to do the whole thing. Same idea, it's still a for loop. It's just that that's a different syntax. The advantage of a for loop is that all three of these things are done in one statement. The initialization, the while, and the update are all done in, and so the only line of code we had to add was the output statement. So the body, is what you put there, but you don't have to put all that other boilerplate around it. I hope I started the recorder again. Yep. So the step value is the amount by which a loop control variable changes. If you're going to count from 10 to 100, your step's going to be 10. I mean, if you're counting by tens, right? You're counting by tens, you add 10 to it every time. You're printing out even numbers, you add 2 to it each time. And you get to specify the step value. I guess I'll scroll this back up above the homework line, make the homework the very last thing. So for loop, you set the initial value, the final value, and the test all in one line, sometimes called the loop header. So for x in range parentheses for x in range 10, that kind of leaves off some of the things, and so they're assumed. Goes from 0 to 9 by ones. Step is equal to 1. For x in range 2, 21, 2, that goes from 2 to 20 by 2's. So the step is 2. So I think you can see what got left off. If you leave that first number off, it assumes you're starting at 0. If you leave the last number off, it assumes you're counting by 1. Now if you want to count by something other than 1, you have to give it a starting value anyways, otherwise it doesn't know, right, which number is which in the little list. So quite often I'll go ahead and put in the starting value, 0, 10, 1, just to reiterate all that stuff. So for x in range 0, 10, 1, that's the long form of the same thing. Yeah, now it's time to stop, I think. Alrighty, any questions, guys? Nope, nope, I'm good. Alrighty, let's make a Dropbox.